Hi, I'm Shane in Sweden, and in this series of presentations, we're looking at the OWASP Top 10 Threat List from 2017. In each of the presentations, we will be describing the problem, giving you some specific examples in C# of how this actual threat works in practice. And then we'll also look at mitigation safeguards we can use when developing in C#. This particular video is part 3 in the presentation on the insecure deserialization threat. I hope you enjoy it. I have a bit of a cold at the moment, so I hope you can forgive the quality of my voice. Okay, so the story so far. In part 1 of this video series, we had an introduction to insecure deserialization. We looked at what it is and why insecure deserialization is actually a problem. We looked at the history behind the growing realization that this was an important threat, ultimately leading to it being included in the OWASP Top 10 Threat List 2017 version. We discovered that insecure deserialization is something that even affects us in the .NET community. I think there were many people who really believed that it was confined to other languages like Java or PHP. In part 2 of this video series, we had a look at insecure deserialization in practice with code examples in C# that illustrate the insecure deserialization problem. We also looked at a couple of different coding techniques that might help make deserialization more secure, and some of these were quite successful, others much less so. In part 3, we're going to look at general strategies for improving security. We're going to look at choices we can make concerning our architecture and the stack we choose to implement. And we're also going to discuss topics that we can take up, for example, in threat modeling sessions or sprint planning. We're also going to look at mitigations we can use as part of our secure development lifecycle. So let's get started. So for an attacker to be able to use insecure deserialization, there need to be some things in place. Okay, this recipe requires certain ingredients. Obviously, we need to have a stream that will be deserialized. The attacker can't do a deserialization attack if there's nothing being deserialized. It's also important that the attacker can modify the content of the stream. Alternatively, that the attacker can actually create the stream that's being deserialized. The important point is the attacker can influence the content. This third ingredient is strictly not 100% necessary, but it is much more likely that an attacker can abuse deserialization if the deserialization stream takes the type information it uses to instantiate objects from the stream itself. And finally, there must be the possibility of deserializing some dangerous type that the attacker can use. So where we're allowing the deserialization of all sorts of objects, the attacker can choose a dangerous type to deserialize, or the actual constrained list that we have of types that can be deserialized itself includes a dangerous type. Okay, so we have 4 factors here, and if we can disrupt one of these things, then we can hopefully prevent a remote code execution attack. So let's look at 3 steps we can take to improve our deserialization security. Okay, so step 1, protect your data stream. The main problem with deserializing untrusted data is that it's untrusted data. If you can protect the data stream that you're deserializing, this is much less of an issue. The question is, how do you protect your data stream? One way is to only deserialize your own streams. So for example, streams that you create and streams that you can guarantee have not been modified after you created them. Jonathan Birch from Microsoft, for example, suggests that streams that never leave your own backend server are safer. So for example, view state information is sometimes sent to the client and then retrieved and then deserialized. This will be inherently more unsafe than streams which are entirely within your own network. Obviously, this is not always possible. You can't always just use streams that you create yourself. And in this case, another alternative is to use a hash-based message authentication code to protect the integrity of your data stream, guaranteeing that you'll be aware if attackers modified your stream in some way. Now, this is actually a very important method, not just in terms of deserialization, but also in improving security around things like RESTful services. And it's a sufficiently useful technique that I may well do a video on it in the near future. However, it's most applicable to use a HMAC in, for example, business-to-business communication. It's not always appropriate when you've got external users who are not actually authenticated within your system and you have no previous contact with them. So it's not always something you can use. A further point when you're using a HMAC is make sure that the key used to validate the HMAC is kept somewhere completely separate from the deserialization system. Or if it's stored in a data store, that the key is not also stored in the same data store. So this is the first step, protect your data stream. Try to use trusted streams that are inside your own network. If you're going to use external streams, try to protect their integrity with some way, possibly a HMAC, and always be careful about the keys you're using to validate your HMAC. Okay, step 2, choose your serializer carefully. Okay, you should plan out which serializer you're going to use, and you should also use it carefully. Think about the way you're using it. Binary formatter probably should not be your first choice. There are other serializers that are more secure by default. For example, data contract serializer or XML serializer. Of course, if these are misused, they can be just as bad. If you have to use a binary formatter, then you really should be considering things like HMAC to protect the integrity. And also you should certainly implement a custom serialization binder so you can restrict the types that the serializer will actually deserialize. Be aware that in many cases your system may actually be using a binary formatter without your knowledge. So for example, anything that reads as resx, for example, the view state in ASP.NET. View state is actually protected by HMAC, and the key used to validate that HMAC is actually the machine key on your server. So if you're using view state, make sure that the machine key on your server is just as protected as other important secrets. So binary formatter should not be your first choice. There are other alternatives. If you're going to use it, make sure you use it properly, and also be aware that you may not have a choice in using it. JavaScript Sterilizer. Right. With JavaScript Serializer, the important factor here is that you want to make sure that the stream is not actually deciding the type. So the type information is not contained within the stream that you're deserializing. So you really want to avoid using the JavaScript type resolver, and in particular the simple type resolver, which allows all sorts of objects to be deserialized. And that's all we really need to think about when we're working with the JavaScript serializer. A very popular serializing agent at the moment is the JSON.NET. Here there's really one major consideration. We should always set the type name handling to none. And again, this is basically preventing us from fetching the type information from the data stream. So there's a number of different settings we can set type name handling to, but the only one we should use is none if at all possible. It should always be the default, and any deviations of this should be carefully considered in your sprint planning and threat modeling sessions. The data contract serializer and the XML serializers they're fairly safe by default. However, once again, it is very important to not take the type information from the stream. How would that happen in this case? Well, someone could have written custom code which parses the incoming data stream, fetches out some type information, creates a new data contract serializer that can handle that type, and then applies it to the data stream to deserialize it. But you really have to create custom code to actually reach this stage, and that's something we would like to avoid. Okay, so we've looked at the ways we can protect our data stream. We've looked at choices we can make when we're working with serializers. Another way, or the final way we can protect our deserialization process is actually to constrain the allowed types, so the types that can actually be deserialized. And this, unfortunately, is a rather hard task to do and to do correctly. Before we actually look at the allowed types, the types we're allowing the deserializer, we can even before then, we can actually constrain the types that our whole assembly that does the deserialization process knows about. In fact, doing this is good. It's an application of the least privilege principle, basic security principle. And that principle, the Much and Anderson book explains, is just a good way of preventing good people from doing bad things. So why would we want to constrain types? Well, a deserializer can only deserialize a type that you allow it to deserialize, and also that it knows about it. It has to know what that type is. If a deserializer does not know what the type is, it can't create an instance of it. If we limit the known types in that assembly, then we limit the number of types that the deserializer can instantiate, possibly excluding a dangerous type. And remember, there is no exhaustive list of known dangerous types currently for the .NET framework or .NET Core framework. So what are these types that it knows about? Well, one is the types in your code, the classes and object types that you actually create yourself. And of course, the other is the types in your framework that you're using, .NET or .NET Core, for example. So how do we constrain these types in practice? Well, there are several tools you can use to get some help here. For example, this is ReSharper, and you can see it has a function at the solution level that you can use to remove any unused references. So it's found the DLLs that the code inside doesn't use. And this may happen when you're refactoring. You refactor out a function, you change a method, and suddenly a reference that you actually have in your solution to another assembly is no longer needed. Now, by removing these references, then we also remove the knowledge of the types contained in those references, and therefore our serializing and deserializing agents will not be able to create instances of these objects. We're limiting the range of knowledge to types that may or may not be dangerous. And remember, in the current time, there is no exhaustive list of dangerous types that exist in the .NET framework. So once we've initially taken the stage of constraining the types that are available, then with particular reference to our deserializer, we can constrain the types that it is allowed to instantiate. Remember, as we tried in our video part 2, typecasting after deserialization is useless. Code execution may have already occurred by the time you get a casting session. The real way to do it is to use a whitelist, which is enforced by a serialization binder. Now, this is not possible for all types of serializers, but it does work, for example, with binary formats and JSON.NET serializers. As we demonstrate, I think we demonstrated one of those lists in our part 2 video. As a further important point when constraining types, if the deserializer comes upon a type that it doesn't know about, it should return an exception. In some situations, may return a null if we don't specify an exception should be returned, and that's not good. The reason being that the deserializer, on receiving a null type, may default back to the defaults binder, which allows all types, and then our whole whitelists process we're doing here is completely useless and bypassed. We also want to keep track of the serialization exceptions, type exceptions. Log these errors and set an alarm in, for example, Splunk if you're using that. If too many of these happen within a short space of time. Type exceptions in a deserialization process, which is happening a lot. It can be an indication that something suspicious is happening in your system. Okay, so if we look at our 3 mitigations there, if we're protecting our stream, making sure we're choosing the right deserializer and that we're handling it properly, and that we're constraining our types, is there anything else we can do? Well, obviously it's good to keep current on the current types and known RC widgets that are available. You might also want to, as an application security expert, do searches in your, for example, Team Foundation server or in your GitHub repositories, and search for these particular types of text, which may indicate that you have an issue with your deserialization, that it might be insecure, and is worth checking the code that handles the deserialization in that area. Finally, of course, it's useful to keep up to date. There's very good information in a lot of online conference presentations, like from DEF CON, Black Hat, B-sides, and so on. And bring these up, bring up this information and discuss when you're doing your planning iterations and when you're doing your threat modeling sessions. And I guess that's really everything I want to say about handling insecure deserialization. I hope you found this somewhat useful. Thank you very much.